Today I'll be talking about radiation safety and protection. So we all know the hazards and the ill effects of the radiation. So we are supposed to protect the patient, the environment, and the operator as well by following a proper technique. So this radiation protection can be done in three ways. That is the patient protection, operator protection, and environment protection. So today I'll be talking only about patient protection. So patient protection can be done by three ways, that is before exposure, during exposure, and after exposure. So before exposure, what are the method we take, and during exposure, what are the method we take, and after exposure, what are the methods we follow to to avoid ill effects or exposure of overexposure of radiation to the patients. That I'll be talking in detail. So before exposure, that is prescribing the dental radiographs and using a proper equipment. And during exposure, use of thyroid collar, use of lead apron, use of fast film, use of film holding devices, and proper exposure factor selection, and following up of a proper technique, and following a proper source to skin distance. These are the methods which are followed to reduce the amount of radiation to the patient during exposure, and after exposure by following a proper processing technique and by properly handling the film. Coming to before exposure, that is patient protection before exposure, under which we have prescribing a dental radiograph. So prescribing a dental radiograph as and when needed, we are supposed to, a dentist should assess the or evaluate the patient's condition, as each patient's condition is different. So it should not be predetermined. The dentist should not have a predetermined thought that predetermined the number of radiograph, so that each patient's condition should be evaluated individually, and the type and the frequency and the number of radiographs needed for each patient, those number of radiographs only should be advised for the patient. It should not be predetermined. So assess the patient's condition on an individual basis and advise or prescribe a radiograph and type of radiograph as and when needed. It should not be predetermined. So next thing is by using a proper equipment, that is use of filters, aluminum filters, lead collimators, and position indicating device. So under filtration, so what exactly is filtration? So filtration is nothing but it is a use of an aluminum disc in your X-ray machine. So that what is the function of this filter is, it cuts out the longer wavelength and low energy X-ray or X-ray photons from an X-ray beam. As your X-ray beam has high energy photons and a low energy photons. So the low energy photons are only contributing to patient exposure, and the high energy photons are the one which will be reaching the patient and the film. And they are the only one which will be helpful for forming a diagnostic image. So only these high energy photons should be reaching the film and the patient. And with the use of this film, with the use of these filters, this can be achieved. That is, the filters, what they do is they cut out the low energy photons or a low energy X-rays, and longer wavelength photons are reduced, so that it results into a high energy and more penetrating useful beam when it reaches the patient and the film. And these are the only one which will be helpful for forming a diagnostic image. So there are mainly three types of filtration, that is inherent, added, and a total. So what is inherent filtration? So inherent filtration is nothing but it is a filtration which is taking place within your glass wall of an X-ray tube and insulating oil and the barrier material until it exits as a useful beam outside the tube. So the filtration which is taking place within your X-ray tube, that is within your glass wall of an X-ray tube, insulating oil and a barrier material, and it exits as a useful beam outside the tube enclosure. So according to government, state, federal government, the inherent filtration should be appropriately for between 0.5 to 1 mm of aluminum for a dental X-ray machine. So coming to added filtration, it refers to the placement of extra disc of aluminum of a diameter of 0.5 mm. So this aluminum disc can be added to the tube head with an increment of 0.5 mm, so that it can be placed between the path of an X-ray beam and the collimator and the tube head seal, so that it absorbs all the low energy photons. So what is the total filtration? So total filtration is nothing but it is a sum of both total added and inherent filtration. So according to state and federal regulation, the thickness of the aluminum for total filtration for a X-ray machine which is getting operated at 70 kVp, it should be 0.5 mm of aluminum. So the X-ray machines which are getting operated at 70 kilovoltage potential, the total filtration or the thickness of the aluminum should be 1.5 mm. And the X-ray machine which are getting operated higher at a higher voltage, that is above 70 kVp, the total filtration or thickness of the aluminum should be 2.5 mm. So that is about filters. Now coming to collimation. Collimation, what is collimation? So as the X-ray beams are produced, they will be divergent. So the function of this collimator is it restricts the size and the shape of an X-ray beam so that the divergent rays or the scattered rays are reduced, so that the patient exposure will be reduced ultimately. So with the use of this collimator, scattered radiation is reduced, and this ultimately reduces the patient exposure and it also improves the image quality. And there are mainly 4 types of collimator, that is slit type of collimator, tubular type of collimator, rectangular type of collimator, and your circular type of collimator. So now coming to the type of collimator which is most commonly preferred, that is amongst all these, round or rectangular collimator is most preferred. Why means with the use of this circular collimator, the federal regulation they have stated that the diameter of the collimated rays should not be more than 2 3/4 inches as it exits the position indicating device and when it reaches the skin of the patient. So it should not be exceeding the diameter of 2 3/4 inches. With the use of the circular collimator, the diameter of this X-ray beam, it is almost little bit more than this mentioned dimension, that is 2 3/4 inches. As you can see, this is our film and this is with the use of a round collimator. So you can see this, the dark area or a region which you can see in the picture is with the use of a round collimator. This is the amount of excess of radiation which a patient is getting exposed to with the use of a round collimator. So because of this, rectangular collimator is most preferred amongst all this. So with the use of a rectangular collimator, as you can see in this picture, the size of a rectangular collimator is almost similar to the size of a type 2 X-ray film which we use. So you can see this is your X-ray film and the dark portion is the amount of excess of radiation with the use of rectangular collimator. So it is almost to an amount lesser than that of, yeah, it is very minimum. The excess of radiation is almost very less or negligible with the use of rectangular collimator when compared to the round collimator. So that is the reason why rectangular is most commonly preferred. So now coming to the use of position indicating devices. So what are position indicating devices? So these are nothing but the extension of an X-ray tube head, which are used to direct the X-ray beam. So again in this, there are 3 types of position indicating devices. They are conical, rectangular, and round. Amongst all this, similar to that of your collimator, rectangular position indicating device is most commonly preferred. So because with the use of this rectangular position indicating device, the exit opening is almost to a range of 3.5 cross 4.4 centimeter in diameter. So with this exit opening, with the use of rectangular position indicating devices, the patient skin exposure is almost 60% less than that of with the use of a round position indicating device. So because of this, rectangular position indicating device is most commonly preferred. So this is your position indicating device and this is your rectangular position indicating device. So with the use of this rectangular position indicating devices, it has an exit opening of 3.5 cross 4.4 centimeter in diameter. So with this diameter, it reduces the patient exposure to almost 60% less when compared to that of your round position indicating device. So that is all that is about patient protection before exposure. Now coming to the patient protection during exposure. So during exposure, what are the measures which we take, that I'll be talking now. So during exposure, use of a thyroid collar, lead apron, and use of fast film holding devices these are used to limit the amount of radiation received by the patient. So first, coming to thyroid collar. So these are nothing but a lead shielded, flexible lead shield which are used or which are worn around your neck, so as to prevent your thyroid gland from the scattered radiation. So these thyroid collars are used only when we are taking intraoral radiograph, that is IOPA, or any other intraoral radiograph such as occlusal radiograph and all. But it is all avoided with when we are taking extraoral radiographs, because it hampers the exposure when we use thyroid collar around the neck, as the machine will be rotating around all around the patient. So when we use this thyroid collar around the neck, it hampers, it absorbs the radiation. So proper exposure of the film in the patient will not be taking place when we use thyroid collar when we are taking extraoral radiographs. Now coming to lead apron. So what is a lead apron? Lead apron is nothing but this is also a flexible shield which is worn on the patient, over the patient's chest and the lap, to protect the reproductive and blood forming tissues from scattered radiation. So this lead prevents the radiation from reaching your radiosensitive organs. So these can be worn while when you take intraoral and extraoral radiograph. In this picture, you can see these are the lead apron. Now coming to use of fast film. So basically, we have three types of speeds of film, that is D, E, and F. So according to ADA specification, film speed which is less than E speed should not be used. So D speed is earlier days they used to use. Nowadays, currently we are using E speed film, and nowadays in market even F speed film are also available. So E speed film is most preferred. So clinically, the film speed of group E is almost as fast as that of group D, and it is almost 50 times as fast as your regular dental X-ray films. So the F-speed films are also available, but and they have an advantage that it requires almost 75% less exposure than that of your E-speed film, and about 40% exposure of about your D-speed film. So X-speed film, with the use of this X-speed film, the advantages are similar to that of a E-speed film, as that such as it has a same latitude, it gives a good contrast as that of a E-speed film also, and the image quality also will be good, similar to that of your E-speed and D-speed film also. So film speed which are slow than that of E-speed should not be used as advised by ADA specification to prevent the patient exposure. Now coming to film holding devices. So film holding devices, these are attached over your what we call it as position indicating devices, so that using of a finger is avoided. So this can be used, this film holding device is used to stabilize the film, and it reduces the chances of movement of the film, and it also prevents the unnecessary exposure of the patient radiation, as if we don't use this film holding devices, people also try using a finger to hold the film. So that should be avoided, because it unnecessarily exposes the patients to radiation. So with the use of these film holding devices, it prevents the unnecessary radiation exposure to the patient also. Now coming to the exposure factor selection. So it is always been advised that the dental radiographer can control the exposure factor by adjusting the KVP and the time on the control panel. So it is advised by the federal government that dental X-ray machine should have an operating potential ranging between 70 to 90 kVp. As with at this operating potential, the patient exposure is as minimum as needed. So it is advised to use X-ray machine, dental X-ray machine, which is ranging between 70 to 90 kVp. So it is always advised to use this exposure dental kilo voltage potential machine. Next is proper technique. So use of a proper technique so that we get a radiograph of a diagnostic quality, and it also reduces the retakes also. Retakes can also be avoided when we follow a proper technique, and retakes can be avoided so that ultimately patient exposure can be reduced. And last is source to skin distance. So source to skin distance. So use of long source to skin distance is always advisable. So it is always advisable. So as it reduces the exposure of the patient to about 10 to 25%. So a distance between 20 to 40 centimeter is advised, or it is appropriate, and it is preferable, and it is specificated by ADA 2006. So that at this range, the rays will be less divergent. So this can be achieved with the use of long cone. So with the use of a long cone, and with you can achieve this long source to skin distance. So with this, we also have a advantage also with the use of long source to skin object distance. It results into apparently smaller focal spot. So as a result of this, the image contrast and the image resolution and the image sharpness, whatever we are getting with the use of a small focal spot, that will be achieved. So these are the measures which we are supposed to take during exposure. Now coming to after exposure, protection of patient after exposure. So once we take a radiograph, what are the methods or what are the techniques which we are supposed to follow to prevent the patient from retaking of a radiograph? That is, we should always handle the film properly. When we process the film, we are supposed to unwrap the film by holding it the edges, and then so that any scratches or any fingerprints or any bending of the film can be avoided, so that we get a radiographic image of a diagnostic quality, and ultimately we are avoiding retakes, so that ultimately we are limiting the patient exposure to radiation. And next method we are supposed to follow to protect the patient from radiation exposure after exposure is, that is by following a proper film processing technique. So we should not either overdevelop the film or underdevelop the film, or over fix the film or underfix the film. Again, it tend to hamper the radiographic quality, so that ultimately we are reducing the retake, and ultimately we are reducing the patient exposure to excess radiation. So these are the method which we are supposed to follow before, during, and after exposure of the patient to prevent the patient from excess of radiation. So with this, I would like to conclude. Thank you.